For quiz 8 for Math 251. Critical values quiz. You're given a function and first asked to find the critical values of the function. Find the critical values, you need to first know the first derivative. Since this is just a polynomial, it's not too hard. What we end up with is 1/3 times 3, which is just 1 x squared plus 2x minus 15. There's our first derivative. Critical values, two different types. Critical values happen when f prime of x equals 0 or when f prime of x is undefined. Because our derivative is just a polynomial, it'll never be undefined. Polynomials are defined everywhere. You can't ever divide by 0 or take the square root of a negative or take the log of a number that's not positive. So all I gotta do is I gotta figure out when this derivative, x squared plus 2x minus 15 equals 0. Probably the easiest way to do that is to factor. You need two numbers that multiply to negative 15 and add to positive 2. Positive 5 and negative 3 are those numbers. So what I have now is either x plus 5 equals 0 or x minus 3 equals 0. So either x equals negative 5 or x equals positive 3. Those are my critical values. Classify the critical values using the first derivative test. The way you do the first derivative test is you consider all the different spots where your first derivative could change sign, specifically your critical values. And you divide the number line up into regions based on those critical values. So in this case, I have 3 different regions. And what you want to do is test a number, arbitrarily pick any number from each of the 3 different regions. So from region 1, any number less than negative 5. How about negative 10? Test x equals negative 10. When I say test it, I mean throw it into your first derivative. So I got to figure out, is negative 10 squared plus 2 times negative 10 minus 15 a negative number or a positive number? Well, I think it's going to be a positive number because negative 10 squared is 100, and that's pretty big. Even if I subtract 20 and then subtract 15 more, it's still going to be a positive number. So what I get is that the derivative at negative 10 is positive, and therefore the derivative at all points in region 1 are positive. What about region 2? Pick any number you want in region 2. I like x equals 0. It's usually pretty easy to test. F prime of 0, that's easy. Change all the x's into zeros, you get negative 15. And negative 15 is less than 0. So the first derivative is negative in there. And then finally, let's test region 3, maybe over here. Pick any number you want that is bigger than 3. I don't know, 10, 4, 5, whatever you want. I'll pick 4, sure. F prime of 4 is 4 squared plus 2 times 4 minus 15. Well, 4 squared is 16. So when I add 8 to 16 and then subtract 15, I'm definitely going to be a positive number because I already have more than 15 just by this 16 right here, and I'm adding 8 more. Definitely positive. Derivative here is positive. So to classify, that tells me, so negative 5 is a local maximum. How do you know that? Because think about it, your first derivative is switching from positive to negative, so my graph was going up, then it stopped, now it's coming back down. Switched from positive to negative, it must have been at a maximum. By that same logic, at 3, my graph used to be going down, then it stops, now it's coming back up. Sounds like negative 3 is a local min. This right here would be our answer. Okay, part C says, do that again, get those exact same answers, hopefully, except now use the second derivative test. To use the second derivative test, you better know the second derivative. Second derivative is just the derivative of the derivative, so it's the derivative of x squared plus 2x minus 15, which is just 2x plus 2. Derivative of this guy. And then what you do is you evaluate your critical values at the second derivative. Figure out if your function is concave up or concave down at those critical values. So I had a critical value at negative 5. So f double prime of negative 5 would be 2 times negative 5 plus 2, which is negative 10, plus 2, which is something, I mean -8, but it doesn't matter what it is. Fact is that it's less than 0. What about f double prime of +3? Well, +3, I got 2 times 3 plus 2, which is 6 plus 2, which is some number, but I don't care what number it is. All I care is that it's greater than 0. Because my second derivative is negative, my function is concave down, meaning it's shaped like this. If my function is shaped like this, and the first derivative is 0, I'm at a local minimum. What I'm saying is because my second derivative is negative, -5 is a local min. And similarly, because my second derivative is positive, it's shaped like this. Flat spot is right here. It looks like a local maximum. -5 is a local min. Whoops, this was supposed to be +3 here. +3 is a local max. -5 is a local min. +3 is a local max. Awesome. Got the same answers. That's a good thing. Determine the intervals on which f is increasing, decreasing, concave up, or concave down. We did a lot of that. Increasing and decreasing I already have. Go up to your first derivative test. My first derivative test, I figured out that my first derivative is positive out here and out here. So my function is increasing from -infinity to -5 and from 3 to infinity. It's increasing from -infinity to -5 and from 3 to infinity. And because it's flat at -5 and 3, that only leaves is where it can be decreasing from -5 to 3. What about concave up? Well, look at our second derivative here, 2x plus 2. What do I do? Maybe over here in a different color. F double prime of x equals 2x plus 2. I want to know when to figure out when it's concave up, I want to know when 2x plus 2 is greater than 0. Subtract 2 from both sides of the equation, divide by 2, you get x is greater than -1, so it's concave up. Anytime x is greater than -1, in other words, from -1 up to infinity. And so therefore it's concave down when it's not concave up, everywhere from -infinity all the way up to -1. Increasing, decreasing, concave up, concave down. All right, so now I have when it's concave up, concave down, increasing and decreasing. In theory, you could sketch a graph right here, but I'm going to get rid of that part. I don't want you to sketch a graph. So I'm going to delete this question off the quiz and just end it there. But before I end it, I want to point out a mistake I made. The second derivative at -5 is less than 0. That's true. The second derivative is negative. But when the second derivative is negative, that means it's concave down. I don't know if I said that or not, but concave down looks like this. When your function is concave down and flat, you actually have a local maximum, not a local minimum. So I should have written local max right here. Similarly, down here when my second derivative is positive, it's concave up, it has this shape. And so the flat spot is a minimum. I should have written local minimum right here. So rather than redo the video, I'm just going to point out that I made a mistake and make myself look like a fool and end the video right there.